I'm the CEO of OpenCV.org. My name is Satya Mallick, and today I'm going to talk about OpenCV 5, the struggles and triumph of OpenCV software. But before we start, I would love to see how many people know about OpenCV. Give me a raise of hand. All right, pretty much everybody knows about OpenCV. That's great to know. So the talk today is divided into these segments. First, I'm going to talk about the library, the current status of the library, a little bit about the history of the library, and then we'll talk about the new OpenCV 5, what are the new features, and then I will have a conclusion. Now, OpenCV library is vast. People do not realize we are such a small team. The team is about less than 10 people, less than 10 developers, and the scope of the library is massive. If you go to GitHub, there are 80K stars on GitHub. There are 7 million downloads a week. That means 1 million download a day. And 89% of the embedded vision engineers, they use OpenCV as the primary computer vision library. And there are about 2,500 different algorithms implemented in this library. So it's massive. Now, a lot of people do not know how OpenCV is set up, who are the organizations that help OpenCV. First of all, we have OpenCV.org, which is a nonprofit that maintains the OpenCV library. This is a US-based organization. Then we have OpenCV.ai. This is a consulting company based out of Europe, and there are several members of OpenCV.ai that help in the development of the library, but this is a for-profit organization. Then we have OpenCV China. This is a China-based nonprofit that helps in the development of the OpenCV library as well. The URL is opencv.org.cn. And then we have a company called Big Vision. This is a for-profit company based out of United States. This not only helps maintain the OpenCV library, we also maintain OpenCV University through Big Vision. Now, there are several parts of the OpenCV ecosystem. First of all, we have the OpenCV library. Most people know the OpenCV library. This is the most widely used computer vision library in the entire world. Then this is supported by our membership program. There are 3 levels of membership: gold membership, silver membership, and bronze membership. And people like the companies like FutureWave which support us through this membership program, and this is primarily how OpenCV is funded. We also have consulting services through OpenCV.ai, and OpenCV.org directly benefits when people go through these consulting services because OpenCV.ai pays a licensing fee to OpenCV.org for using the OpenCV name. The same thing is true about OpenCV University. This is a collection of courses that help people start from the very basics and become experts in not just OpenCV, but also PyTorch, TensorFlow, GenAI, etc. So if you're looking for courses and a career path in AI, you should visit opencv.org/university. And again, OpenCV University also helps fund the free OpenCV library. Now, if you look at OpenCV at a glance today, it consists of various parts. The very common usage is the input-output module, which is called HANGZHOU. This is very commonly used for reading images, displaying images, etc. And then we have several core data structures, which is the matrix, class, exceptions, etc. And then on top of it, we have built several modules for image processing, transforms, fitting, optical flow, segmentation, calibration, features, 3D, RGBD data, deep learning module, which is very popular now, and computational photography. So these are some of the modules that are currently in OpenCV, and we'll see how this whole structure is being modified with OpenCV 5 in just a bit. Now, OpenCV has, this is the 25th year of OpenCV. In fact, when I was a grad student, I used OpenCV myself in my work. It is that old of a library. And it all began in 1998 when Dr. Gary Bradsky started a computer vision library inside Intel. And in the year 2000, he decided to open source the library. The primary motivation was that at that time, a lot of people were interested in computer vision research, but they could not use all the different algorithms that were being implemented. They were not open source. So the labs which actually had these algorithms already implemented, they had a huge advantage in research, but other people did not have that advantage, right? Let's say companies from Microsoft, people from Microsoft and other places, they had a huge advantage because these algorithms were implemented in their internal libraries, but other people did not have access to it. So even to do canny edge detection, you would implement everything from scratch. But fortunately, Intel decided to open source the library, and in the year 2000, it became public. And in CVPR 2000, this was released as the OpenCV library. Initially, it was called CV Lib or CV Library, and later it was called OpenCV during the time of release. Now, a lot of people do not know that OpenCV has a stellar legacy. It was part of the DARPA Grand Challenge. In 2005, DARPA arranged this Grand Challenge for autonomous vehicle, and for the first time in human history, a vehicle traveled 132 miles in the Mojave Desert autonomously and won the DARPA Grand Challenge. The name of the vehicle was Stanley, and the name of the computer vision library it used was OpenCV. In 2006, OpenCV version 1 was released. This was primarily a C library. And then came the most important change in OpenCV, which was OpenCV 2.0. With this, it became primarily a C++ library, and Python support was added with OpenCV 2.0. And now the popularity of the Python module is so high that almost half of the downloads are because of Python. And then came OpenCV 3.0. We also released the Transparent API along with OpenCV 3.0. Transparent API enabled you to write code once, and the same code would transparently run fast on many different devices without you needing to change the code at all. And then we released in 2016 the DNN module, which has become very popular now. So you can use most of the ONNX-based deep models with OpenCV. And this is just for inference. We do not do anything for training because we know that people are going to train the models using PyTorch or TensorFlow, and then you can bring it to OpenCV and it will run really fast. Now, OpenCV 4.0 was released in 2018, and it included support for C++ 11. And then came OpenCV 4.5, which is the current stable version. One of the major changes was that we moved to the Apache license. Now, Apache license is about the same as the MIT license that is currently that was used before. It is, it is a very permissible license. You do not have to pay anything to OpenCV to use OpenCV even for commercial purposes, right? So that was a library change. And OpenCV 4.5 also, it is the stable version of OpenCV right now. And now we are working on OpenCV 5, and this is a major, major overhaul of the library. So you have to be very careful while upgrading to OpenCV 5. It is coming this winter. So let me explain the various parts of OpenCV 5 and what are the new changes and what motivated some of those changes. So here are the various things I'm going to go over. Let's start with better language support. In the C++ and C domain, there is one bad news or good news, whatever you want to call it, but it's an important news. C API is being deprecated. So people who are using the OpenCV C API, not the C++ API, but the C API, where you use IPL, image star, that kind of syntax, that is being deprecated. And this may have implications to a lot of companies that use the C API or started out as the C API. We recommend that they upgrade to the C++ API. As far as the C++ language is concerned, C++ 17 is now the minimum recommended version of C++, although C++11 will also continue working, but we recommend that you upgrade to C++17. And very soon, we are going to add support for C++20 as well. Now, we have enhanced support for Python. First of all, Python 2 support is deprecated so that we can focus on Python 3 and above. And we also have a very tight integration, very good support for NumPy 2.x, and we have a deep integration with NumPy. The Python bindings, which used to be an afterthought, actually the Python module was not even created by OpenCV team itself. There was a community contributor who decided to release versions of OpenCV Python, and that is why it was always behind a little bit. It was a single person maintaining it. Finally, we talked to the contributor, and he generously gave us access to the code base, etc. And now OpenCV Python is being maintained by OpenCV team. We also plan to have named parameters in C++. Now this, in Python, people are very familiar with named parameters. If you want to not worry about the order of the parameters, you can simply name the parameter and pass in the values. It's very convenient, but this is currently only available for Python users, and this thing is being transferred to the C++ version as well. We are also making major changes to the core module, which I'll talk in the next few slides. But as part of that, we are, the Python array API standard we are adopting it. Now, treating images as matrices, and 3D matrices and multidimensional matrices, this idea started with MATLAB. And when we saw that, OpenCV, when it was starting out, we decided to copy that kind of idea, which is great, right? And treating images as matrices had many good benefits. But with the, with the new deep learning libraries, the matrices are not, three-dimensional matrices. It's not like height, width, and channel anymore. Usually, we do batch processing, right? Images are not processed individually. And that is a big change. So we decided that we will go with the community standard that is being implemented in the Python array API. And we will stick very closely to the Python array API. So that's going to be very, we'll make sure that we are future compliant because we are moving with the community. And then OpenCV core is going to align with this standard as well. As part of OpenCV 5, we will have a faster and smaller core. The reason we decided to have, pretty much we are re-implementing the core from grounds up for several reasons. The very first reason is performance improvement. You will see a 2 times performance improvement on mathematical functions. We'll also have transparent acceleration, which means that once you write the code, you do not have to worry which hardware it is running on. You could have accelerated versions of these APIs on different hardware, no matter where it is running, CPU, GPU, NPU. Under the hood, we will do the acceleration, and you will not even have to worry about what code, the same code is going to run. We are also implementing features like broadcasting that will improve programmer happiness. And if people don't know what broadcasting is, let's say you have 2 different matrices, and they are not the same size. You want to add the matrices, and there is a chance to make the rows and columns a certain size so that that operation is valid. That is what broadcasting is all about, and we are going to implement that in OpenCV 5 as well. And one of the changes that happened during this evolution of the OpenCV library is the DNN module, right? Starting 2012, deep learning became a very important piece. So we added the DNN module. But as we added the DNN module, some of the core functionality remained inside the DNN module and not inside the core module. With OpenCV 5, we are changing that. We are moving some of the important functionality back into the core so that all algorithms can benefit from it, not just the DNN module. And finally, as I had mentioned, that we are going to future-proof the array library implementation by making sure that it adheres to the Python array API standard. Now, with OpenCV 5, we also have universal intrinsics. It means that we are natively supporting FP16 and BF16 intrinsic support. This means that initially, if you use the current version of OpenCV and you have a deep learning model that was trained on 16 bits, right? It is you still are able to read the model, but under the hood, it actually doesn't use 16 bits. It uses 32 bits for reading the model and running the model, which means that it is not very efficient. But with this FP16 and BF16 support, the models, if they are in that format, in FP16 format, it will run natively in FP16, which means that some NPUs, et cetera, which have acceleration for FP16, it will be able to utilize that. We're also moving to a nicer template-based intrinsic specification. For example, instead of VX underscore set 0 underscore U8, which is not very pretty, we are going to move to VX underscore set 0 and then have the template implementation, which would be uint 8 underscore T, right? The standard C++ way of implementing it. And then we have expanded support for mathematical intrinsics, and this is how we are getting 2x improvement in mathematical functions like sine, cosine, log, etc. Now, the interpolation method has also been improved substantially. This is all under the hood. You do not have to make any changes to your code. Things will just be faster once you upgrade to OpenCV 5. As an example, we did this, we have been working with ARM, and before the Neon optimizations, you can see that we received about 3 to 4x improvement in 1D and 2D interpolation methods, right? That's quite substantial. Think about it this way, that you upgrade to OpenCV 5, and suddenly some of these functions start running 3 to 4 times faster, and you did nothing else. No change to the code, and suddenly this starts running very fast. And we are also making it, the SIMD intrinsics for image resizing, warping, and remapping are being implemented, and they will be available in OpenCV 5. We also have a shiny new image processing module. As I mentioned that with deep learning, the standard now is you don't actually process one image, you process a batch of images, and the same concept is being added to OpenCV. So you can use OpenCV batch processing with OpenCV 5.x. It will not be part of OpenCV 5.0, but very soon we are going to release a second version of OpenCV, which will enable this. We will also have smart parallelism, and this means that some of the functions like warp affine, which you have been using for a long time, they will have parallel implementations. They will get faster under the hood without you needing to write any line of code. And similarly with FP16 and BF16, we have the infrastructure in place, but this is being rolled out to the OpenCV image processing module as well. Again, we also have much better ONNX compliance. And finally, all the ugly fonts that we had in OpenCV, which did not render very nicely. I mean, it was very functional, but it was not pretty. That problem is fixed, and also international languages, that problem is fixed with UTF-8 support as well. There is a new hardware acceleration layer in OpenCV. Now, a hardware acceleration layer is a piece of software that allows you to write code once, and it automatically recognizes what hardware it is running on, and if there is acceleration available for that hardware, it will transparently use that. For example, if you write a piece of code, and let's say you did not have a GPU, then it will run on the CPU. But let's say you had the GPU, and there is hardware acceleration available for that GPU. In that case, it will automatically be using that GPU, and you will see your things run faster. You do not need to write any specialized code. It does everything transparently under the hood. And we are working with several companies to make this happen. For example, if you're running on ARM hardware, we are working with ARM to use CLIDCV as the backend. So the way hardware acceleration layer works is you see the API, which is transparent. You don't need to know that it is going to run on ARM. But when you install OpenCV on ARM hardware, it will recognize that CLIDCV is available, and it will use it directly. The same thing with Qualcomm. We are working with Qualcomm to enable FastCV when OpenCV runs on their chipset. And the final thing is RISC-V. We are working to make RISC-V a first-class citizen of OpenCV as well. With OpenCV 5, there is a major cleanup of the library. The features module, for example, it replaces features 2D. And we are also implementing DNN-based features. So some of the features are very popular, like SIFTs, ORB, FAST, etc. But we also recognize, even though they are popular, they are not the best, right? There are deep learning-based features which are stunningly good, and we are implementing those as part of Google Summer of Code this year, and they will be part of the OpenCV library. Some of the popular features, which unfortunately are not state-of-the-art anymore, they will still be available, but they will move to OpenCV contrib. And then the same thing with object detection. We used to have HOG cascades and HOG features, etc., and they are no longer state-of-the-art. These things will move to OpenCV contrib, while new deep learning-based methods will become the default for object detection, etc. And then the classic machine learning modules, we are basically moving them all to OpenCV contrib, because I think that scikit-learn does a much better job of implementing these features, and we recommend people use scikit-learn for these features. And if you still want to use OpenCV, you can always compile it with OpenCV contrib and continue using it. Approximate nearest neighbor algorithm, initially it had its own separate module. We are making it part of the features module, and now we have a much better Annoy-based ANN search, which will be part of the features library. And finally, we are also deprecating the graph API. It is moving to OpenCV contrib, and we have dropped support for OpenCV VX. Part of this effort, all this effort of deprecating things and making it cleaner, is because over 25 years, we have implemented a lot of things which made sense over the years, but now they don't make sense. So we want to remove things from the library, make it smaller and more faster, etc. Similarly, the photo module will have major enhancements. It will have support for Macbeth chart detection, color calibration, and correction pipeline that's moving in the main OpenCV library. The Calib 3D module, it was a collection, it had gotten really messy. So we have divided into 3 parts. One is the 3D module, which does basic 3D geometry, and 3D vision functionality will be implemented in this module. Then we have the Calib module, which is the calibration module. We will also support multi-camera calibration. And finally, we have the stereo module, which will have algorithms for depth estimation. The deep neural network module is also going a major overhaul. We are supporting more and more of the ONNX parser. Now, this ONNX standard is pretty vast. It is impossible to actually comply with the entire standard, but we are making sure that all the popular computer vision related models are supported by OpenCV. Similarly, the data types, int8, int32, etc., they are being supported, which means that things will run much faster because they are not being converted to FP16 while running using OpenCV. And we'll have better support for backends like OpenVINO, which will use OpenCL acceleration. Now, in terms of some of the new models that are being added to OpenCV, we have stable diffusion model. Now you can use stable diffusion natively inside OpenCV. And here we also have an example where you can use it for image in painting. And the documentation is being improved quite substantially so that a lot of things are moving. You'll be able to try these things in the documentation. Now, we are also aware that now computer vision is not a separate thing anymore, right? Things are moving towards unifying. Things are getting unified now. And we have vision language models that support both vision and text. So we thought that we have to implement some of these things. The LLMs, some of the LLMs will be implemented in OpenCV. They will run natively in OpenCV. And as part of that effort, we implemented GPT-2. And there is, in the link you can see here, there is an example code where you can see GPT-2 running on your using OpenCV. And this is setting up the stage for vision language models in the future. So we also have better 3D support. We have support for 3D visualization and texture mapping, and Charuko board support for robust multi-marker and multi-camera calibration is also coming. And internally, we are experimenting with 3D Gaussian splats and camera read localization. This is in research stage, but hopefully this thing will also be implemented in OpenCV 5 quickly in the next few months. Finally, we have better documentation. We have updated the documentation quite substantially. We have a team working on this. Many new samples have been added, and many new samples old samples have been updated as well. I want to conclude by saying we have a lot of friends in China, and I'm looking for other collaborators who can help grow the OpenCV library with us. So I want to thank our gold members, FutureWay, as well as Huawei was a gold member until recently. And these contributions from these companies, they help us support the library. They're crucial for keeping the library free for everybody. We also have collaboration silver membership for Orbec. This is a 3D camera company, and we have worked with them in 2 roles, as silver members as well as development partner. Now, in development partnership, it's not a donation program. It's gold membership, silver membership, and bronze membership. These are donation programs. Companies come to us, donate money, and usually they don't expect much in return. But we also have something called a development partnership, where the companies give us money so that we can work with them to implement things which are relevant to them and very important for the community. So Orbec has been working with us. We have supported, now Orbec cameras, they are supported with OpenCV. You can actually plug in an Orbec camera, which is a 3D camera, RGBD camera, and it will, OpenCV will recognize it, and it will be able to get information from the camera. Kada's Vim3 is the first dev board that supports OpenCV. And it uses quantization and so to make things faster. Now this board, without the work that we did with them, used to run 10 times slower, but now with the work we did with them, it runs 10 times faster. So conclusion, OpenCV 5 will be ready this winter. It's a major upgrade. There are major performance improvements, but also, and there are major API cleanups, but also be aware of backward compatibility. We have deliberately broken things so that it's a one-time pain, but moving forward, we can develop the library faster. I have a bunch of resources. When we share the slides, if you share the slides, you can go over these resources as well.
Thank you.
Thank you so much.